Good morning to all. We are batch number 9 in Jansen's Institute of Technology, Department of Computer Science and Engineering. Our project is an AI gesture interface for sterile processing of radiology images, guided by Ms. R. Ashwini, Assistant Professor CSE, presented by Madan T, Narmadi GP, Sandeep J, and Sudarshan V. Abstract: the interface employs a deep learning model to recognize hand gesture and translate them into intuitive command for navigating through medical images. The system is designed to allow clinicians to browse and analyze images without the need to touch and physical interface, thereby reducing the risk of contamination in sterile environments. The results show that the proposed AI gesture interface can provide a safer and more efficient solution for medical image analysis. Introduction: medical imaging plays a crucial role in the diagnosis and treatment of various medical conditions. Radiology images are a key component of medical imaging, providing detailed information about the internal structure of the human body. However, the use of physical interfaces such as keyboards and mic in the analysis of radiology images can pose a significant risk of contamination in sterile environments. The proposed interface employs a deep learning model to recognize hand gesture and translate them into intuitive command for navigating through medical images. By eliminating the need for physical contact with the user interface, the proposed system reduces the risk of contamination in sterile environments. It provides a safer and more efficient solution for medical image analysis. Existing system: currently, the most commonly used interface for the analysis of radiology images is a physical keyboard and mouse. However, in sterile environments, the use of physical interface poses a significant risk of contamination as they are difficult to sterilize. A study conducted by Lee et al. Proposed a gesture-based interface for controlling a robotic surgical system, but it not reliable. Drawbacks: limited functionality, reliability issues in noisy environments, may not be specifically designed for a use in sterile environments, may require a learning curve for user to get used to the gesture recognition interface. Problem definition: potential risk of infection transmission in radiology workflow, lack of efficiency due to traditional input devices requiring physical contact, need to touchless and sterile solution for radiologists to interact with medical images. Merits: improved reliability in noisy and challenging environments, specifically designed for use in sterile environments with features that ensure complete sterility. Intuitive and easy to use, requiring minimal training for user to become proficient. Compact and portable, making it easy to use in a variety of clinical settings. Provides an alternative to traditional physical interfaces such as a keyboard and mouse.
Block diagram. In this, we have to first collect the data and we have to process the data because the data can be unstructured. After processing the data, we have to test and train the data using the algorithm CNN. In that, the CNN is used convolutional neural network. After that, we have to evaluate the test and train data. For that, we have taken the test image data and we have to evaluate. After evaluation, the trained model will be get the user upload the images through user interface, and then the user gives the input to the HD cam. Then our software will predict the accurate answer for the hand signs. For example, resize, blur, flip, zoom in, zoom out. Software requirements: hardware HD cams, Intel 5 or Intel 7 processor. Software: Python, machine learning, image processing libraries. Module setup: gesture recognition module, image processing module, user interface module, machine learning module, calibration module, integration module, data storage module, security module. Modules: Module 1: gesture recognition module uses computer vision algorithm and machine learning to track and interrupt hand gesture made by radiologists. Highly accurate and able to recognize a wide range of gesture potentially including gesture for zooming, rotating, and panning radiology images, designed to work in the variety of lighting condition and positions such as standard or sitting. Module 2, image processing, responsible for loading and processing radiology images, potential from the local or cloud-based database or other storage system, designed to optimize image quality and provide fast loading time, potentially through the use of compression algorithm or other technique, designed to support a variety of image viewing modes such as axial, coronal, or sagittal view, seamlessly integrate with the gesture recognition and the user interface module, allowing radiology to quickly and easily browse and manipulate radiology images using hand gestures. Module 3, user interface, designed to support a variety of screen size and resolutions from small laptop or large monitors or multi multi-monitor setup to adapt different display orientation such as landscape or portrait mode, responsive and fast, providing immediate feedback to radiology as they interact with the gesture recognition module and manipulate the radiology images. Module 4, machine learning module, to process large volume of data, potentially including images, to generate trained dataset for machine learning module, able to train machine learning modules such as convolutional neural network to recognize and classify hand gesture accurately and efficiently. Designed to minimize model size and complexity, allow for fast and more efficient inference on the gesture recognition module, designed to allow for customization and fine tuning of machine learning modules based on a specific user re- requirement or use case.
Calibration module to account for individual differences in hand size, shape, and motion, as well as variation in lighting and other environmental factors, designed to guide radiologists that allow them to train the gesture recognition module to recognize their specific hand gestures accurately and reliably. It includes features to adjust the sensitivity or specificity of the gesture recognition module. Integration module 6. It includes features to support integrations with external systems or APIs such as electronic medical record EMR systems or third-party data analysis tool. Manage data flow between the different modules, ensuring that data is passed accurately and efficiently between them. Designed to support different hardware and software platforms and can used on a variety of devices and operating systems. Module 7, Data Storage Module, to support data sharing and collaboration, allowing radiologists to access and review patient data from remote locations or different devices. Designed to ensure that data is accurate, complete, and consistent. Designed with scalability and extensibility in mind, allowing to handle increasing volumes of data over time and to support future updates and enhancement. Module 8, Security Module, responsible for ensuring the security and privacy of patient data and other sensitive information. It includes features to authenticate and authorize users, ensuring that only authorized personnel can access patient data or use the tool. It includes features to monitor and audit user activity, allowing for suspicious or inappropriate behavior to be identified and investigated. Survey of problems. Difficulties in accessing radiology images securely. Lack of standardization in image formats and data structures. Complexity and time-consuming nature of traditional radiology image browsing tools. Need for more efficient and effective tools for image annotation and diagnostic reporting. Analyze the problem. The security and privacy of radiology images and patient data is a top concern for healthcare professionals. Effective image annotation and diagnostic reporting tools are critical for radiologists. Developing accurate and reliable gesture recognition algorithms can be challenging and require significant amounts of data and expertise. It must be designed with user-friendly interface in order to maximize usability and adoption. Finding the solution. The solution is to help the healthcare workers a sterile-free environment and prevents the risk of spreading infections. reduce the use of traditional methods like using keyboards, mouse, etc. Assembling the kit. First, we have to connect the camera. After connecting the camera, we have to install the required libraries, such as image processing libraries used for machine learning, artificial intelligence and machine learning. Make sure the camera runs properly and predicts the gesture. Coding the program. The program for recognizing the gestures and processing of the MRI images are made to work by coding in Python language using machine learning algorithms. Here we have used CNN algorithm, which is called convolution neural network. The image is uploaded by using a web interface developed using a Python framework called Python Flask. Testing and implementation. The assembled kit will be tested for its proper working and quality. If the quality and working is proper, it will be implemented in various places and user feedback will be collected. Based on the feedback, if further enhancement is required, the product will be improvised further and provided to the user so that the customer need can be satisfied. Conclusion. In conclusion, the operating rooms and the hospital environment is no need to be sterilized after surgery. That is less contamination of disease in OR. The security and privacy of patient data must be a top priority. The development of accurate and reliable gesture recognition algorithms all present significant challenges. It has the potential to enhance the efficiency and accuracy of medical image analysis and diagnosis. Future enhancement. Additional user interface improvements to make the interface in virtual reality or other emerging technologies. Increasing security and privacy by including additional encryption and authentication features to protect sensitive patient data. Improve diagnostic reporting and analysis tools and NLP to make it easier for healthcare professionals. Integration with augmented reality to create even more powerful and versatile tools for medical image analysis and diagnosis. Results. Uh, the first picture shows that our project is running in the software, running the software in command prompt, and after that, there will be an IP address for a Flask FTP server, and by copying the IP address and pasting on the browser, we'll get an user interface stating that please upload your result. In that we have to upload our radiology images.
And here we need to upload the radiology images from our device. After uploading that, the webcam will automatically enabled. After that, the image will automatically manipulated based on hand gesture that is provided by the doctors. So the hand gestures will act like rotating, zooming, zoom out the images, previous image and the next image. So in this image, we are seeing that our project is running on while performing a surgery. These are the algorithm we are using in this project to train the model. And these are the algorithm we are using in this project to testing the model. These are the references we are taken to execute our project. Thank you.
To run our project, first we need to open the command prompt in the search window. After that, we need to provide the project folder path in command prompt. First we need to copy the path of the folder. After that, we need to paste it into the command prompt, cd space the path of the folder. To execute our project, first we need to provide the command python main.py. After that, our project is running on Flask FTP server. So here our user interface will be opened. Here we need to upload the radiology images from our device. We need to choose a multiple images from our device. After that, upload into our user interface. Then again we need to provide the same command python main.py to enable the webcam. After providing that, the webcam will be automatically enabled. Then the image will be manipulated according to the hand gesture that is provided by the user. So here we have different features like flip images, previous image, rotation, page down, page up, so zoom in and zoom out. So these are the features we are providing in this project. So here the radiology images are automatically zoomed in and zoomed out based on the user input, based on the hand gesture that is provided by the user. So the image is automatically rotate and zoomed in and zoomed out. So these kind of the features we are provided in this project. And again, one more option we are provided in this project. Inline images can also be manipulated based on the user gesture input. So here the inline images can also be manipulated, zoomed in, zoomed out, and previous image and the next image according to the gesture input that is provided by the user. So here the images will be moved up and down. And zoomed in and zoomed out based on the hand gesture. And rotate right and moved left, previous image and the next image will also be manipulated. So in inline image also can also be image rotation and zoomed in, zoomed out features will be performed in our project. So, and this is our project. Thank you.